Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize and landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays and the functions of the Boeing 787-900Z aircraft. I'm gonna start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in 10,000 feet per minute, of the stiffness of the trigonometric angles in degrees he can climb and descend. We have also the artificial horizon with the altitude indicator, the pitch ladder in degrees and the bank angle in degrees, the artificial horizon, and also the Lszh localizer. We have the Lszh localizer on board antennas of the aircraft that receive the radio frequencies transmitted from the threshold antennas of the runways we use for takeoff and for landing. So we're going to be aligned with the horizontal localizer on the vertical glide slope for approach and landing. You're going to see how I'm going to use them. So we're going to have the horizontal localizer and the vertical glide slope for alignment with the magnetic north pole heading of 136 degrees. For approach and landing with the Zurich International Airport, the Lszh in Switzerland, runway 14. So we have also the Lszh localizer crossbars for, and also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode annunciator with the autopilot and the auto throttle, later and vertical navigation modes. We have also the HSI, the horizontal situation indicator that displays the magnetic heading and track, and also the integrated display of the flight plan we're gonna create. So we're gonna create a flight plan later. You're gonna see the purple magenta line with the waypoints and the stars displayed that we have to follow. We can use either automatically using the autopilot flight director system panel or manually. So I'm gonna have to show you also the navigation display. The navigation display that displays the GPS position of the aircraft, the inertial reference position, the magnetic north pole and the geographic north pole, and magnetic variation depending on where we are in the world. You can see we have the terrain and weather reflections from the weather radar. You can see with red, green and yellow color the reflections from the radar. You can see the terrain in front of you, the terrain map also with the airports. You can see our own airport, the Zurich International Airport at Lszh in Switzerland. We're going to use for takeoff and for landing. We have the runway we're going to use for takeoff and for landing, and the taxiways, the runway leg and its heading. So you're gonna see also the other airports. We need to fly into another airport. We have also the VOR stations, the ADFs and the Bs, the navigation aids, the nav aids, also the waypoints which are horizontal and vertical navigation fixes and altitude and airspeed constraints. We're gonna select some waypoints from the flight management computer later when we create the flight plan. So you will see how we're gonna use the flight plan, the magenta or purple line. He's gonna connect all the waypoints one with another for this flight. So we're gonna have a route or a flight plan or a flight path for this aircraft. I'm gonna show you also other systems: the autopilot, flight director system panel, the auto throttle, thrust levers. Over here you can see. So we have the thrust levers, the flight controls, the flight management computer. So you can see the flight controls I'm using to fly the aircraft. I can climb and descend. I can make turns to the left and turns to the right. So this is the pitch axis, the roll axis, left and right turns, the control wheel, and also the rudder pedals. We have the yawing axis. So you can see also the thrust levers. I'm using this switch here to control the thrust function when we're gonna be flying later. In the end part of the video, you're gonna see the complete flight from takeoff, climb, cruise, descent, approach and landing. So you can see also the engines indications here. You can see the primary flight display, what it displays. You can see we have the airspeed tape with the airspeed indicator. Right now the airspeed selected from the autopilot flight director system panel displayed with purple or magenta color. So we have also we have the altitude tape with the barometric altitude above the sea level 1430 feet. The barometric pressure of the outside atmosphere 29.92 inches of mercury over here. The radio altitude, the minimums. The vertical rate of climb descent of the aircraft in 100,000 feet per minute. The vertical speed indicator, so use this needle moving up when climb, moving down when we descend. The pitch ladder over here in degrees. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down. The pitch altitude of the aircraft inside. Also the bunker over here, this degrees means how many degrees. So we use this for the bunker over here, and we use this for the pitch altitude over here. The pitch ladder, you will see the pitch altitude change and the vertical speed indicator. So we have over here, you can see also the radio altitude above the ground level, 2 feet, minus 2 feet. You can see the ADF, left and right, the frequency 0284, the heading selected here, 360 degrees. So you can see the airspeed heading over here. So this is the autopilot flight director system panel. You see airspeed heading and vertical speed is 0, and altitude is selected, so it's 210,360 degrees. Over here is the same as displayed here in the primary flight display with purple color. So you can see 210,000, then we will change the value. You have different indication, 360 degrees heading. You can see the barometric altitude setting for the barometric altitude is 29.92 inches of mercury, give us 1430 feet. So you set the barometric altitude over here. In this panel, the FS panel, electronic flight instrument panel, you have inches of mercury, hectopascals, minimums, radio bar, weather radar, traffic and terrain on the display. You can change plan, map, menu, range, the range of the map here. So right now we have 80 nautical miles. You can accept, cancel or reject some warnings over here. So you can see the terrain map, the airport we are located, the terrain, red, yellow over here. Red is 4,900 feet here and here, and yellow is 1,600 feet. Is closer to our own elevation right now. You will see later, you can see also the vertical over here. That was the horizontal. You can see how many thousand feet above the ground level. You can see 10,000 like in the autopilot. This line is 10,000 feet like the one we have selected over here, 10,000 feet display. So you can see the range is 80 nautical miles. The ground speed, you're gonna see the wind direction speed when we fly, the magnetic north pole and geographic north pole, and the magnetic variation depending on where we are in the world. We have the magnetic north pole, geographic north pole. Also you can see the navigation display using the transporter, the ADSP and ADC transmitter receiver that transmits our frequencies to other aircraft, and the air traffic controller receives from other aircraft. You can display in the navigation display the other aircraft using the transponder radio frequencies. You can calculate the other aircraft distance from our aircraft, altitude difference in hundreds or thousands of feet, whether they are higher or below our aircraft, whether they climb or descend with respect to our aircraft. And also you can calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning. Using the TICA system, the traffic collision advisory system, it will show us in the navigation display the other aircraft with a diamond shape. We can select also that anytime. So you can see also we have other things we need to see. So we have the autopilot flight director system panel. You can see autopilot engage, disengage, so the left and right, flight director, LNAV, VNAV, lateral navigation, vertical navigation, airspeed in nautical miles per hour knots, flight level change, climb continuous auto throttle, heading and bank angle, hold vertical speed, for localizer approach. So you will see all the functions in a few minutes after I'm gonna show you a couple more things. You can see also the engines indications from the FAREX. We have the FAREX. I will show you later. You can see the engines indication, the left engine, right engine. The FAREX are the full authority digital electronic control computers, one installed per engine. So you can see the N1, which is the low speed starters, low pressure compressor, and turbo under the turbo fan to the engine, left and right. Exhaust gas temperature per engine. N2, which is the high speed starters and high pressure compressor, and turbo under the turbo fan to the engine. The fuel flow per engine per 1,000 kilograms or thousands of pounds. Over here, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. The outflow valves and the cabin altitude, rate of climb and descent. This is the pressurization of the aircraft display. So you can see differential pressure, landing altitude, gross weight and total fuel on board. You can see other things also, landing gear over here, extend or retract, landing gear is done, the flaps position, stabilizer trim over here and rudder trim. So I will show you stabilizer trim. You will see this switch later in a couple of seconds. Of minutes we're gonna start using the stabilizer trim. I'm gonna show you the flight controls and the rest of the systems of the aircraft of the Boeing 787-900. So I will show you also a little bit the flight management computer. We have the flight management computer to create a flight plan or a flight path or a route. So I'm gonna use the mouse pad here to control. You can see the mouse pad that I'm having here. Left and right, the touch screen of the mouse pad. So I'm having also this mouse pad here. So you can see I'm using also this mouse for controlling the function of over here of my flight management computer over here, as you can see. So I use this to insert I want. You can select either one over here in the screen. So we have the index over here, identity, position, performance, takeoff, approach, annunciate, status. You will see later the modes one by one. After we're gonna make some more systems. Before that, annunciate data, flight plans, traffic control, load plan, safe plan. So you will see how I'm gonna use this in flight. We have also the keyboard over here, the alphanumeric keyboard to insert all the data we need. You can see also we can use that for this screen over here. So I'm gonna show you also a couple more things before showing you the flight controls. You can see over here the flaps position. If I move the thrust levers forward, so we can retract or extend. The flaps we're gonna move the way we want. You can see the flaps movement here. Right now it's 25, we can fully extend. You can see them also extended here 25 degrees right now. We can retract also. So this is what extends and retracts the flaps over here. Flaps position. It displays over here in the screen. You can use like 0 degrees the flaps. So you can see now we have less flaps. Now they extend, they are in transition. Keep moving. So we have also the speed brakes here, extend and retract. You can see the speed brakes like this, extend and retract. So we have also the fuel flow, the thrust levers. You can see the auto throttle disconnect switch, this switch here, the takeoff ground, the thrust levers, the fuel control to the left and the right engine, We have the fire extinguishers for the left and the right engine, the transporter, the radar trim over here. So we have also the stabilizer trim, the cutoff switch, and the alternate trim channel, so you can trim the horizontal tail of the aircraft like this, pitch up or pitch down. The parking brakes over here you can set. So I'm gonna show you now how to use the horizontal trim stabilizer and other flight controls. Also gonna show you my side stick, how I use the Lszh Stream 3D, my side stick here, how to control the flight controls of the Boeing 787. As you can see, we can climb, you can descend, you can make turns to the right, turns to the left. You have the horizontal trim stabilizer here. This switch, when I fly, I can use. Also the thrust levers over here. We move the thrust levers forward and aft, change the position of the thrust. The FAREX produce the necessary thrust, give the command to the engine. So you can see here we have the horizontal trim stabilizer. This switch to control the horizontal tail of the elevator for climb or descent, for pitch up or pitch down. So when you trim the elevator, as you can see, elevator trim, hope you can see in the display. So this is elevator trim, left click down, right click up, as you can see. Elevator trim, left click down, right click up over here. So this way you trim up, you pitch the nose of the aircraft up, and this way you trim down, you pitch the nose of the aircraft down. So this is the effect you have when flying using this flight control, the elevator trim switch, as you can see. Again, elevator trim switch. So this way you pitch the aircraft nose up, this way you pitch the aircraft nose down. You have the head up, also the clutter and the autopilot disconnect over here. This switch, the flaps also, speeds. So we have a flight by wire aircraft. It has a flight control computers. So this is how to trim the elevator up. You will see we can move the elevator also using the side stick here for climb and for descent when flying. So we have also the alternate. This is the normal channel. We have the primary flight control computers function over here. We have them connected to the auto position, as you can see. Primary flight control computers in the auto position. We have the normal, the alternate and the direct mode, like in the Airbus aircraft. We have the flight control surfaces over here, air data computers, other function. So this is some of the computers we have in the aircraft. When you move the flight controls, the yoke, the others, the spoilers in flight, you give a command to the flight control computers. We would change the position of the aircraft. Flight controls to command the attitude of the aircraft in flight in terms maybe of G acceleration, like in the Airbus aircraft. For climb, descent, or making turns, G acceleration. So you have also hydraulics over here, which move the flight controls. You see the flight controls move when we move the hydraulics. So we have also here, so we have the normal over here. We have the alternate channel over here. You can see again stabilizer trim, pitch up the nose and pitch down the nose over here. You trim the elevator up or trim the elevator down. We have a couple more functions, also the navigation radio. You can see here high frequency VHF, SAT, ground proximity, weather radar, transporter. So we have also this red guarded switch. It's the stabilizer cutoff switch over here. As you can see, you open up and move from normal to cutoff, either the left or the right horizontal stabilizer, auto trim, or both of them. So if you have a failure that affects the flight control computers that is generated from the hydraulics over here, you're gonna have a failure of the auto trim function of the Boeing 787. Because this is a fly-by-wire aircraft, it's fly-by-wire aircraft. It has the flight control computers. So you have a failure from the hydraulics that will affect the horizontal elevator or stabilizer trim. You have to disconnect the auto trim function, the automatic trim. So you will use only the manual trim switch in flight. So you come down here and you open this red guarded switch from normal to cutoff over here. It's for all Boeing 737, 747, 757, 767, 777 and Boeing 787 aircraft from normal to cutoff. Then you have the manual trim switch over here. As you can see, trim the elevator manually, or using the normal or the alternate trim channel. So you have also the alternate in case you have failure maybe with the normal. So you can see nose up or nose down, pitch trim, and you can see how many degrees you pitch up or pitch down the aircraft. You have the stub trim over here. Right now it's 4.5 degrees, is within the takeoff limit of its weight. You have also the rudder trim over here. So this is a stabilizer trim, nose down or nose up. So we have a few more flight controls to see, as to the elevator and also aileron spoilers, the control wheel, the thrust levers. Also the outside view of the aircraft. Right now we'll talk to you about Newton's physics, aeronautical and aerospace engineering and derive some principles and some aerodynamics functions we need to know. Also for the air transport pilot license and for the commercial pilot license for flying the aircraft. So also over here so you can see the surface area of the wings hold the weight of the aircraft, the forward wings mainly as we fly. So we have the thrust vectors also from the engines, the jet propulsion. You can see the exhaust from the nozzles of the cones of the exhaust. We have the forward, the fans, the compressors, the turbines of the jet engines. So you can see also we have the mean aerodynamic chord here. The Mach is 23% of the mean aerodynamic chord, where the maximum aerodynamic lift occurs in the forward wings. It's also the position where the stall, the center of pressure is moving above the wings, and also the stall will begin when we fly. The airflow will become detached all the way back, and the aircraft wings are going to be stalled for a given angle of attack in flight. So you need to monitor over here the primary flight display when you fly. You can see the airspeed, the stall speed will be given here with a yellow and red indication. Also the angle of attack of the aircraft as we fly, that affects also that. So we have also here the mean aerodynamic chord, where the maximum aerodynamic lift occurs. Also is where the center of gravity is usually located. We have the right and left wing fuel tank, the center fuel tank of the aircraft. So we have also the vertical axis, which is also the yawing axis. We use the rudder over here to make yawing turns of the aircraft, left and right yawing turns like this. So this is the rudder pedals. Also we have the nose wheel for making yawing for turns in the ground. For nose wheel steering, so you can see the rudder pedals here. This is what moves left or right. We have the nose wheel steering, the tiller is interconnected many times with the rudder pedals. So from it's deflecting 76 degrees either left or right, the forward nose wheel, until 45 knots in takeoff. Then it decreases to 7 degrees either left and right, 7.6 maybe, until 70 knots airspeed in takeoff. We have the rudder aerodynamically effective from 45 knots over here. So you lose the forward nose wheel above 70 knots. You have only the rudder. The rudder is aerodynamically effective from 45 knots. So you use that for directional steering for yawing turns over here, as you can see. So this is the yaw, the rudder pedals. We have also the lateral axis from wingtip to wingtip is the elevator control, the pitch axis. So you can pitch the aircraft up and down using the elevator or stabilizer trim of the aircraft, as you can see. So we have the horizontal tail function like this, as you can see, climb and descent. So you can see here we have the elevator for climb and for descent like this, the pitch axis. So we have also over here from nose to tail transverses the other axis is the longitudinal axis, the roll axis. The roll axis, the left and right side stick or control wheel. For the Airbus is the side stick, the elevator. For the Airbus aircraft elevator and ailerons and spoilers. For the Boeing is the control wheel. Use the roll axis. So you can see ailerons and spoilers left and right turns over here. So we have the roll axis like this. So we have all the flight controls together, interconnected. You see the side stick deflection is proportional to the yoke deflection. Both captain and first officer move together unless we have a failure in flight, and not like in the Airbus you have the side stick priority for either the left or the right side. So I'll show you one more view of the aircraft flight controls, and we will continue with the rest of the systems of the aircraft before we going into a full flight. In the end part of the video you will see the complete flight from takeoff, climb, cruise, descent, approach and landing, full manual. So stay with me until the end part of the video, and I will show you the flight controls, how I use the side stick, the lock stick, extreme 3D for the Focatron, the elevator, the ailerons, the spoilers, the rudder, and also the thrust levers, the horizontal trim stabilizer, the flaps and the slats, and the speed brakes. So we have full flight controls like this. So you can see here have this Lszh Extreme 3D side stick. You see also the thrust levers here, and we have this view also. So also use this view. Hope you like. So you can use also. So we can climb and we can descend. We can make turns to the left and turns to the right. So this is how climb, make turns to the right, make turns to the left. Yes. Ναι, είδα. Είδα, ωραία ήταν. Ναι. Λίγο πιο καλά είμαι. You can climb, you can descend, you can make turns to the left, to the right. Hope you also have a good view over here. So you see we have the full flight controls. I hope you like it. Also the engines over here. You can see the engines function moving forward like this. Here's full takeoff. So this is all the flight controls. We need to know for now. Also the outside view. So this is all the flight controls lesson. For now we go for the rest of the systems. We need to know, so we go for the flight management computer over here. So I will show you how to create a flight plan or a flight path or a route. I'm gonna use the flight management computer. I will input all the data of the aircraft for this flight, that includes the empty weight plus the parts of the passenger, plus the cargo, plus the fuel on board, where the fuel is on the left and the right wing. In the center tank we have 30% the left and the right wing tanks and 10% the center tank. The flight management computer is going to calculate automatically the center of gravity of the aircraft for these loads, and also from takeoff as we fly, cruise descent, approach and landing. During the whole flight the aircraft is going to burn fuel, so the center of gravity is going to be shifted and it's going to be recalculated every second from the flight management computer. That gives also commands to the autopilot flight director system panel, the auto throttles, and the flight control computers, and the FADEX for the engines, and for these electronic control computers. So you're gonna see all these things. The flight management computer is gonna calculate before takeoff the center of gravity, the mean aerodynamic port position, the mark where the maximum aerodynamic lift occurs before the wings before the stall begins. We need to monitor the stall. We're gonna have the horizontal trim stabilizer for takeoff, like 4.35 degrees, just before takeoff. Set 15 degrees of flaps. We're gonna select the runway. We have the runway 14 in the Zurich International Airport, Lszh in Switzerland. So you're gonna see the runway length, the runway slope, the wind direction, the speed, the barometric pressure, the density of the air, and the temperature of the air, and also the runway conditions. If it decides dry wet, it's gonna give us the takeoff speeds V1, V-rotate, and V2. We're gonna use 15 degrees of flaps, full takeoff power like 100%, and 9 degrees of pitch attitude for rotation. For climb, so you're gonna have 140 knots approximately, 150 for takeoff. Then we're gonna have also the seats, the other instrument departure, waypoints and fixes, and include horizontal, vertical navigation fixes, and altitude and airspeed constraints for the initial climb and departure of the aircraft. We're gonna have to climb to the cruise level, like 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're gonna cruise there over 30,000 feet. We're gonna make some turns, follow some waypoints. You're gonna see them in the navigation display. Then we're gonna initiate the descent back to the elevation of the airport, like 7 or 6,000 feet above the sea level. We're gonna align with the stars as other terminal arrival waypoints and fixes, and include horizontal vertical navigation fixes and altitude constraints about the terminal approach and landing of the aircraft, and long final and short final, and altitude and airspeed constraints. So you have also we have the Lszh localizer, the instrument landing system of the runway we use for takeoff and for landing. The runway 14 in the Zurich International Airport, Lszh in Switzerland. We're gonna have the Lszh localizer frequency from the radio antennas transmitted into our aircraft. We're gonna receive them from the onboard antennas of the aircraft. Is gonna be aligned us with the magnetic northwest heading of 136 degrees of the runway for landing. So we're gonna have the horizontal localizer and also the vertical glide slope to follow with the Lszh localizer crossbows. We're gonna have 25 to 30 degrees of flaps for approach extended the landing gear down, a pitch attitude of about 9 degrees or less, and also an airspeed of 160 170 knots, or about 270 300 kilometers an hour. So we're gonna see the approach and landing, the full flight, and also the full flight plan. I'm gonna show you now how to create the flight plan here using the flight management computer. So we go in this section, the control quadrant, so you can see the mouse pad here that I'm gonna use. Another view of the cockpit. So you can see I can change either mode here with the mouse pad over here. So I have the entities, Boeing model 787-900 GNX engine, the Iraq cycle, and the position Lszh airport. It will give us an IRS alignment if we need, inertial alignment index. So we have performance here, zero fuel weight plus fuel on board. We have the gross weight for takeoff. Also we're gonna use the cruising altitude in flight over here, as you can see. Cruising altitude in flight, cost index over here, fuel freezing temperature in flight -37 degrees, and also center of gravity in flight, the reserve fuel. So we're gonna set first the route Lszh, departure and arrival, destination airport. We clear the discontinuity. Then we have runway 14, route departure arrival. We set departure over here. So we have we can use either departure runway 10, 14, 16, 28, 32. So we select runway 14, and the seats, these are the instrument departure waypoints and fixes. We're gonna use the seats Zui to Alpha. So we have departures here, the arrivals, Lszh arrivals. So we have VOM 162834, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we have ILS 14 over here, Transamiki, Transnegria over here. So we have the stars as other terminal arrival waypoints and fixes, the legs. You can see the route with blue over here displayed. The heading, first waypoint, is not yet activated. Climb to the Zui, the distance from one waypoint to the other. Climb to the Negria over here, then descent, approach over here, Zurich, approach and runway 14 and landing. So we go again to the initialized performance. We use zero fuel weight 322.7 thousand pounds plus 34.2, the gross weight 355.9, the reserve fuel 5%, the fuel on board 34,200 pounds, 25,300 is the cruise altitude for this flight, and the cost index is gonna be 100%. Fuel freezing is gonna freeze the fuel at -37 degrees, recirculate the fuel to 80% center of gravity. So we press the execute, you'll see now the route with white and purple over here is activated, heading 136 degrees, 2 nautical miles, 250 knots, 1900 alpha is the first waypoint, second 1 nautical mile, third 3 nautical miles, fourth 5 nautical miles, 6 nautical miles. This is Zui, 301 knots. This is the flight plan of the aircraft, 6000 alpha. The Negria heading 071. We make a left turn over here for Zui. We turn left. Then for Negria, 26 nautical miles from Zui, 301 knots, flight level 22,200, Mativ, 230 knots. We make a right turn here, 12 nautical miles, 320 knots, 11,800. We descend for approach and landing over here. I make it 258 degrees heading, 6 nautical miles, 190 knots, 10,400. Ella. Zui, we have 9 nautical miles, 187,000 alpha over here. Zurich Z8701, 6 nautical miles, 186,000 alpha. So make TRA 180 knots. Έλα. Δεν μπορεί να περιμένει λίγο να με δώσει το τηλέφωνο από εκεί, γιατί θα χαλάσει το βίντεο πες. Για το αεροπλάνο. Δώστε μου από εδώ. Έλα.
Έλα ρε βλάκα, γιατί δεν σηκώσει το τηλέφωνο.
Τι θες όμως, γιατί τώρα έχω το αεροπλάνο, σε λίγο, σε 20 λεπτά θα το ανοίξω.
Ρε φτιάξω το τηλέφωνο και σε θέλω σε 20 λεπτά και σε μισή
Μα
ώρα.
δεν γίνεται, θα μου κλείσει το βίντεο και θα πρέπει να το
με πάρεις
ξανακάνω.
τηλέφωνο όταν τελειώσει από το αεροπλάνο κατευθείαν.
Εντάξει, άντε τα λέμε. So we approach for landing over here. Runway 14, 8 nautical miles, 140, 1,450 feet. So this is the complete flight plan over here. We set the flaps for approach and landing, and the center of gravity 4.25. The V1 V-rotate and V2 gross weight, takeoff gross weight. So we have over here departure arrival, alternate, VNAV, progress, hold. We can use a waypoint to hold, the fix, navigation radio for approach and landing over here. So we're gonna use the aircraft now for going into takeoff. So this is the complete flight plan or flight path route. Now I'm gonna initiate the procedure for starting up the engines for making a flight. So you can see we also have a couple more things to see here. The navigation display. You can see the waypoints over here. One waypoint by another. You can see the runway we're gonna use for takeoff over here. The taxiway, the other runway. The climb rate over here of the aircraft, the terrain. So you can see the taxiway in front of us, the other runway over here, and the terrain as displayed from the flight plan and the GPS. So we have a few more things to see over here. Look a little bit further away. You can see here we have the Germany, the France and the Switzerland, the terrain map with the airports. Also we can set over here the center view. You can see the vertical over here, how we're gonna fly and cross either waypoint over here. So this is for navigation purposes. We have also this, the plan display over here. You can see how far away we're gonna be flying. The waypoints one by another. You can see other aircraft also. So this is the map we're gonna use. Now we're going for the flight. I'm gonna show you for the flight over here. I'm gonna show you how to use the APU. We're gonna start the APU, the auxiliary power unit. I'm gonna talk to you about the engines function also. We have the FAREX in the engines, the full authority, digital electronic control computers, one stop engine gearbox, float channel redundancy, one time phase, the other takes over, controls, monitors, the displays all the engine functions. You see in the upper and lower ACAS engine indication equalizer system display like the N1. Which is the low speed starter, so have low pressure compressor, to one of the turbo hunter engine, exhaust gas temperature per engine, N2 which is the high speed starter, so have high pressure compressor, to one of the turbo hunter engine, exhaust gas temperature per engine, fuel flow per engine per hour, 1000 kilograms per pound, so the pressure, the temperature, the quantity, and the vibration of the N2 states of the engine over here. So you can see also we have the cabin pressurization states here. So we use cabin pressurization. In the manual mode you will see what it will display over here. In the engines indications. So also the FAREX control as we climb into higher altitudes like 20, 30 or 40,000 feet above the sea level. As we climb higher in the aircraft, the pressure of the air, the density and the oxygen level become less than half than that of the sea level. So we have a higher airspeed of the aircraft also. The aircraft flies with 2 or 3 times faster than that of the sea level, so we have higher intake of airflow from the front fans of the engines for compression and fuel mixture. So the FAREX, the fuel authority, the electronic control computers control the fuel mixer automatically, the fuel flow to the engines, the fuel metering unit. Also, as we fly higher to higher altitudes, we have freezing temperature like -30, -40, -50, -60 degrees below zero. below Celsius, below 0 Celsius. So we have freezing of the fuel in flight. So we recirculate the fuel automatically from the FAREX, also from the left and the right wing in the center tank into the engine components to heat up the fuel and cool down also the engine. And also we do the same for the lubricant and the oil. We have the recirculation of the oil and fuel, which is done automatically from the FAREX. Also the FAREX controls the pressurization inside the engines. If we have an overpressure and under pressure, we can open the outflow valves into higher lower state. The outflow valves of the 5th and 9th states also supply the wing and engine, the ice, air conditioning and ventilation, cabin pressurization, oxygen regulation in flight is supplied from pressurizer from the engines and from the bypass of the engines. And also for the hydraulic fluid tanks pressurization, all the flight controls you see here. We move the wings up and down, left and right, the landing gear, the flaps, thrust reversers for the engine. We have the hydraulic fluid tanks over here. So we start the APU. We need to proceed for the engine start. The lighting of the aircraft over here. You can see we have the left and the right IDC, 100 to 200 volts, 400 Hz frequency, 20 volt battery. Primary flight control computers over here in the auto position. We have the air data computer that displays all the air data you see here, the airspeed, altitude, GPS position, magnetic north pole, laser gyroscopes, inertial alignment, the altitude of the aircraft. So we have flight control surfaces, towing, FD door, towing power, passenger oxygen, window heat over here, rammer turbine, left and right engine driven, hydraulic pumps, turn to the off. We see what happens. We turn back on. We have the electric for a backup and the rammer turbine, and then to the auto. Wing and engine are the ice over here. You can set on or auto. You can see we have also the lighting system of the aircraft and the windshield wipers over here. We have the recorders. We have the cargo and APU fire over here. We have the electronic engine control for the engines, for the FAREX and normal and alternate mode. The auto start over here, these switches. We can dump some fuel to lose weight over here and on the nozzles and how much to remain. Also you can see we have the fuel booster pumps left and right wing, center. The crossfeed valve can feed either engine with other pump or either tank, or balance the fuel between the left and right wing. So this is also, we have the bleed air from the engines for air conditioning, ventilation, cabin pressurization, oxygen regulation. So we have the outflow valves, climb, descent, manual, automatic, we need to do nothing. So I'm gonna show you also the last thing before making the engine start demonstration over here. We have the systems display over here. You can see the hydraulics over here, APU is running, oxygen, liquid cooling. So the oxygen of the aircraft, liquid cooling, electrics, left and right IDG, the APU is running, 120 to 200 volts, 400 Hz frequency, the drive APU and main battery, voltage and amperage. So this is the electric, hydraulics. You can see where the hydraulic fluid goes, which system use it. The left and the right engine, electric C1 and C2. We have 5100 psi and how much quality we have. The shuttle valves also. The fuel left and right wing tanks, center tank we have 11 and 11 and 11,000, total 33,600. Low and high pressure fuel valves in the left and right engine are open and feed from the center of the wing tanks. The APU is fed from the left wing using the DC motor. Over here the crossfeed valve is off, but we turn it on. You can feed either engine with other pump or either tank. Also the minimum fuel temperature right here, we recirculate the fuel automatically, as you can see, because it will freeze in flight. You can see minimum fuel temperature minus 37 degrees and the fuel temperature right now. So we have the automatic from the FAREX which heat up the fuel. The air pressurizer from left and right engine from the APU. The doors are closed, the cabin can be pressurized over here. The gear, the pressure of the tires and temperature of the brakes. The flight controls here, we can move. The flight controls, you will see the deflection of each flight control, the tail also. So this is the last thing to check over here, the flight controls. Also we have the FS display, status, maintenance over here. and circuit breakers maintenance also. And also we have the checklist over here, which is digital also. Normal menu, what to do before start, before takeoff, after takeoff, descent, approach, landing. So we go now for the engine start demonstration over here. We need to turn off both engines and restart them. So both engines in the off position, you see, we turn off both engines. So you see the messages now. We have the engines off, and you can hear the roar of the engines. The hydraulics are off, so we go over here in the overhead panel and set the auto start over here in the automatic in the start. So auto start, we have the reconfiguration, the amber color, and you can see we have only pressurizer inside the engines right now, above 20% APU running. So we have 20%. We can start the fuel flow now to the engines, both fuel control left and right on. So the auto start initiates very quickly. So we have both pressurizer from the APU right now and fuel into the engines. The auto start 49, 50, 51. So you see the messages are going off. At 60% we're gonna be having running engines, both engines running, as you can see. So we can go for takeoff right now. Flaps for takeoff, parking brakes off, advance the thrust levers. We take the clearance from the air traffic control and we go for takeoff. So we need to align with the runway heading over here. So we are still in the taxiway. We have the runway in front of us. We hold if we need, so we align the heading of the runway over here, the center line. So speed brakes up, thrust the full takeoff, thrust levers full takeoff power. So we press the yoke down until 100 knots. We align with the rudder pedals. Have some side wind. V1. We rotate over here. You can see what happens when you have side wind and takeoff. So landing gear is up. We have positive rate of climb. We had a lot of side wind in this takeoff. So you can see here the data after takeoff. We have the airspeed 188 knots, the stall speed. We are 2,000 feet above the ground, but 3,700, 2,400 above the ground, but 4,000 above the sea level. We climb with 5,900 feet per minute. The stall speed here and the airspeed, the flaps position, the pitch attitude of the aircraft, the wind direction and speed over here. So we keep climbing. We need to pitch down a little bit, as you can see. So you can see also the engines here. Also how far above the ground we fly right now. We are like 3,000 or 4,000 feet above the ground level. You can see the terrain below us. These green waves. So if we look a little bit further away, you will see the red, green and yellow with the horizontal terrain map. So we need the flight plan, also the outside view. So you can see the Switzerland here, the lakes, the airport. Just take off from this airport, the international, and also the Swiss Alps here. So we're gonna make the turn now. We initiate the turn for the flight plan, and we have 16 more minutes to go. So we set also this. Climbing here. We need to align with the flight plan. We have the air data again. As you can see, the flight management computer also data. Gonna make a small left turn here. Have beautiful views over here. So hope you like the outside view of the aircraft as we overflying the Switzerland, the Swiss Alps, the Galaxy also, the star sign, the Germany, the France. So we're gonna be flying over those are. You can leave the hands off from the side stick, no problem. The aircraft keeps flying itself. Should make a small left turn over here. To align with the flight plan, and we have 12 more minutes left. So we are at 20,000 feet. You can see a nice view of the cockpit as we climb through 30,000 over here. So now maybe we have to start the turn in a couple of minutes. So you can see how far above the ground we have the France here, the Germany, my homeland, the Bayern Munich. Over here the lakes and the Swiss Alps, the Switzerland. So we are almost 7,000 meters above the ground. So make the turn here, as you can see. It's gonna have the handles now. So this is how we turn manually over here, as you can see. So this is the frozen vapors over here from the aircraft engines exhaust. Hope you like it, and we have like 10 more minutes for this flight, maybe less. So we're going back to the airport, as you can see. So you can leave the hands off, no problem. The aircraft keeps flying itself. Like this, as you can see. So flaps up, full up. Pitch down the aircraft a little bit. So this is the view from almost 33,800 feet over here. So this is a nicer view over here. Keep climbing, as you can see. Let's start the descent. We enter a stall over here, so we need to apply the stall avoidance to avoid the stall. So we pitch the aircraft down, as you can see, and full thrust forward. So this was the stall avoidance over here, as you can see. So we're going back to the airport. We have 6 more minutes to descend to the airport, as you can see. So fast idle, and we have a few more minutes, like 6 more minutes for approach and landing. So we are flying very close to the airport area right now, and we have 5 more minutes to go to the airport. Keep descending, as you can see. So you see the stall avoidance, how we made it. Now we need to start for the turn over here. Follow the waypoints for approach. Use a little bit left rudder here. A little bit more thrust. So we need 3 more minutes for approach and landing over here. So we are very close to the runway now. We can increase the rate of descent here. Use some flaps. Align with the runway here. So we are in the final approach and landing over here. Increase the rate of descent over here. And we have a little bit more than 2 minutes for approach and landing, as you can see. So this is when we need to have the altitude of the aircraft. We have the Lszh localizer. We can watch how to follow the Lszh localizer for approach and landing. So we have some side wind and some wind gusts to combat with for approach and landing, as you can see. So a little bit more wind gusts over here, so we align. Makes more difficult to align the aircraft when we have lateral side wind. So we're gonna be having the flare here. Gonna be flaring the aircraft, as you can see. A beautiful flare over here, touchdown, very, very beautiful. Parking brakes here, idle thrust and reverse engines. So this is how we slow down the aircraft, as you can see. So you can see all landing gear is perfectly safe for nose wheels. So we use idle thrust as reversers off, and you can see all landing gear parts over here are safe. There is no breakage of any wheel, so the aircraft is standing up the way it should be in the runway. Also you can see the runway we just landed over here, how much time we have also. So that